Hello chemistry class, it's Mr. Ng, and here's a short tutorial on how to do electron configurations. So here is the first problem in your homework set. It's nitrogen, and I have both the problem here, I'm asking for the electron configuration, and I have a periodic table. This is an important tool for us. So let's first locate nitrogen, and as you can see, nitrogen is right here with an atomic number of 7. So that means a neutral nitrogen atom will have 7 electrons. I'm just going to write 7 right here. That means I got to fit in 7 electrons. So here I have these little shells already pre-prepared for us. And all we got to do is fit in 7 electrons. And the notation looks like this. 1, 2, 3, 4, 5, 6, 7. Notice a couple of things. Number one, I started at the lowest energy level first. That's called Aufbau's rule. Aufbau's rule says you start with the lowest energy level. Number two, notice that when I filled up my 2p, I did unpaired arrows first before I start to pair them up. That's called Hund's rule. And lastly, notice that within one little orbital, they get opposite spins when you fill it up. This is Pauli's exclusion principle. So again, all I got to do is fill up those arrows with those rules, and I end up with this notation. Look, 1s, so I'm going to write 1s. There's 2 electrons here, 2 electrons, 2, 2s, 2s, 2 electrons, so I put the little 2 up here, and then finally 2p, and 3 electrons, 3. And I could check my answer by adding these numbers up here. 2 plus 2 plus 3 is 7, so I know I got the right answer. Good? Let's try another example. This time we have vanadium. Vanadium is right here. It's got an atomic number of 23. Before we start filling in the little arrows for vanadium, I want to take some time to remind you of our orbital blocks. This block up here is your s block, and hydrogen is the beginning of 1s. This block over here is our p block, and boron is the beginning of our 2p. Similarly, this huge block in the middle, right? All our transition metals. This is our D block, and scandium is the beginning of 3D. And then finally, these guys down here are lanthanides and actinides. This is our F block, and lanthanum is the beginning of 4F. So it's an easy mnemonic to go 1S, 2P, 3D, 4F. The smallest level for D is 3. There's no such thing as 2D or 1D. The smallest level for F is 4. There's no such thing as a 3F orbital. Makes sense? So here, there's a little trick that you can do. Now that we know that this row is basically 3D, vanadium is the third one in. Look, 1, 2, 3. So we know it's going to end in 3D3, 3D3. But let's fill in our arrows and see if that's true. Look. It's got an atomic number of 23. I'm just going to write 23. So let's count 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Look, 3D3, just like I said. And now we can fill in the rest. This is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. One last thing that I want to teach you here. You don't need to write all this craziness, right? All this 1s2, 2s2, blah, blah, blah. Instead, there is a shortcut. Here, let me show you. Here, instead of writing all this gobbledygook, 1s2, 2s2, 2p6, blah, 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 right? Let's just get down to 3p6. 3p6, this is 2p, this is 3p. 3p6 is argon. So instead of writing all this stuff, 1s2, 2s2, blah, 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 why not just write it like this? Argon, right? This whole box is argon anyway, so let's just write argon, and then we'll write these guys. This is 4s2, and then these guys, 3d3. Good, right? Again, all these guys here, all the way up to 3p, right? This filled up p orbital. This is basically argon. So instead of writing all that junk, I just write argon in a little bracket, and that makes things way easier for me. Let's try that trick again. Here is sodium, right? But instead of writing all the electron orbitals all the way to sodium, why not write this thing first? Why not write neon? Neon. What goes after neon is sodium, and look, it's in 3s, 1, 2, 3, right? And it's an s, 3s1, 3s1, and I'm done. Way faster this way. Let's try one more. Let's try mercury. Mercury is all the way down here. It's huge. So again, our same trick is to do the noble gas of the prior level. So I'm going to draw a line of the prior level. So here, this is our last noble gas. So I'm going to do my shortcut, and I'm going to write xenon. Xenon takes care of it. And here, now I just got to take care of this and that. So this is 6s, right? 6s2. And here, this is 3d, 4d. So this row is 5d. FYI, there are two elements here that we need to fill in, right? These guys actually slide right in there. So this is 5d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to do xenon. Fill these guys up, right? 6s2. And then this row, this gets getting a little messy. Let me erase this. All right. This row is 5d, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5d10. There you go. That's the electron configuration of mercury. I mean, it could have been really big, but I did my shortcut. That makes it a lot easier. Thank you very much for watching.